Hello there, Mustangs. This is Miss Cecil, and today we're going to be looking at another way of solving system of equations, but today the method we're going to be using is called elimination. And with elimination, the key thing that we're looking for is when you have your systems of equations, you want to check to make sure both of these equations are in standard form. So basically what that means is that your x terms are first, followed by your y terms, and those are set equal to your constants. So once both of your equations are in standard form, this is usually the preferred method, elimination, to go ahead and solve the system to get your solution. So the first thing we're going to do is we're going to look at our x terms and we're going to look at our y terms. And we're going to look to see if either of these have the same coefficients or opposite coefficients. So right here, if we look at our x terms, or bubbles with the x's, we have a coefficient of 7 and we have a coefficient of -5. So 7 and -5, those are not the same and they are not opposite, so this is not ideal. However, when we come over here and we look at our terms with the y, or our bubbles with the y's, we see that there's actually a coefficient of 1 right here and another coefficient of 1 right here. And that's actually great because that means we have to do less math and less work. So what we're actually going to wind up doing is we are going to see if we can actually either add or subtract these two equations together to try and get these terms to cancel out. So let me ask you this. Should we add y plus y to get a 0, or do we need to do y minus a y to get a 0? I hope you said we needed to subtract, or we needed to do a minus here, because y minus y equals 0. So that's actually going to be our first step. We are actually going to subtract this entire equation from this equation. So we are going to subtract all of this from all of that. Okay. So when we do subtraction, what's going to actually wind up happening is this negative is actually going to be distributed to every single term. So what winds up happening, if you do a negative times a -5x, this right here will actually turn into a positive 5x. This negative times this positive y will actually turn into a negative y. And then over here, this negative times this -29 will actually turn into a positive 29. So now we can drop down our first equation again. And we could just add these together. So 5x plus 7x gives us 12x's. And again, the whole reason why we're doing this is because we're trying to get these to cancel out. So a negative y and a positive y, that makes a 0. But when we're solving equations, we don't actually write 0. Then we have an equals 29 plus 19, and that's going to give us 48. And the whole reason why we're doing this is because we got these to cancel and make a 0, we now have an equation with only one variable in it that we know we can solve for. So now our new equation is going to be 12x equals 48. In order to get x by itself, we need to divide. And if we divide this side by 12, we have to divide this side by 12. The 12s cancel out to give us a coefficient of 1, leaving us with just an x. And over here, 48 divided by 12 is 4. So now we know what x equals, but again, when we're solving systems of equations, we're actually doing this math to get an ordered pair. So all we have found right now is our x value. We still need to figure out what our y value is. So just like in our substitution method, now that we know what x is, we'll actually go ahead and plug in the value of 4 into one of these original equations to figure out what y is. So again, it doesn't matter which equation we plug this into. In this particular equation, I think our top equation might be a little bit easier, so we're not dealing with negatives. So we're going to go ahead and rewrite our first equation, but when we get to the x, we're going to stop, and we're actually going to put parentheses, and instead of writing that x, we're going to write 4 because our x value is actually now 4. So we're going to go ahead and rewrite our first equation, starting with 7. Then instead of the x, we're going to put parentheses, and because x equals 4, we're going to write 4. Then we go back up here and we add our y, and that is equal to 19. So now we just do the math that we see. So 7 times 4 is 28, plus y equals 19. Last step to get y by itself, we're going to have to create a 0 pair here. So we're going to have to subtract 28 from each side. Again, making a 0 pair, drop down our y. 19 minus 28 will actually give us a negative 9. Again, on your number line, that's like going up 19, but going down 28. So you'll be all the way down at a negative 9. So now that you have your y value, you have your y coordinate. So the solution, or the point where these two lines will intersect, is going to be when x is 4 and y is negative 9. So the solution to this system of equations is 4, negative 9, and the method we used to figure that out, or to solve the system, was elimination.